weekly captured orbit. But the good news is we only have about 6 more minutes to go, and at that point we'll be finished with our orbit for today and getting ready over the next few days to move into our commissioning orbit.
Excellent. So, Rich, as the LRO project scientist, what's your role in this incredible lunar mission?
Yeah, I have the great job of working with the 7 instrument teams, with the project here at Goddard, and then also with the instrument builders and the headquarters folks to work on the instruments. This shows the crater instrument, our radiation sensor, the lunar radiometer experiment that will measure the temperature on the moon, our 5-beam laser altimeter, and then our high-resolution cameras, which will make very precise images of the moon, a UV spectrometer to search for water frost in the polar regions, and then a neutron detector from Russia that will look for hydrogen at the poles. And then finally, our technology demonstrator, an advanced synthetic aperture radar system. And this shows the spacecraft here at Goddard in its final testing.
So, Rich, tell me a little bit, how are these measurements that you just talked about through the other video, how will they aid humans in the return to the moon, especially for extended periods of time?
Right. In order to return safely to the moon, we have to identify a level terrain. Our 5-beam laser altimeter will measure precisely the unevenness of the terrain and identify here in green safe landing sites. We look at the temperature of the moon, and from the temperature variation we can tell rock abundances. And then finally, our camera system is able to measure objects that are only a few feet in diameter and find small craters. And by combining all of this information, we'll be able to tell where it is safe for explorers to land, here shown in green, and then after they land there, they can explore the nearby regions.
So, Rich, tell us a little bit more about what resources you're hoping to find on the moon.
Yeah, searching for resources is a very important goal. The one resource we know that is on the moon is nearly continuous sunlight. When explorers land in the equator, they're faced with 2 weeks of sunlight and 2 weeks of darkness. This video here shows the normal variation of sunlight on the moon. The moon rotates in 1 month. But here at the poles, we see that there are regions that are high elevations, like hills or small mountains, where the sun shines nearly all the time. And explorers can use this sunlight as a source of electric power and of warmth to survive for longer periods than they could at the equator. Also at the poles, we see that there are permanently shadowed regions, the bottoms of craters, that get very, very cold, here shown in blue. And we think that over the course of the last 2 billion years, water and other volatiles on the moon may have settled here, and then they've condensed, and they can be used as a resource for not only human consumption but also for rocket fuel.
Well, that's just great. I think I just heard that we're about 20 seconds
right
from the end of the burn.
That's a very important milestone.
So just tell us, hearing that, are you really excited to learn? What are you hoping to learn from LRO?
LRO is going to give us an atlas of the moon. It'll start to unlock the secrets of the moon, and there are many interesting places on the moon, but I personally am most excited about what we'll learn about the polar regions. The polar regions are the terra incognita, the unknown lands, and we think that those are going to be important destinations, and we're very excited about what we'll learn there. And now they're just telling us...
All stations is displayed. Congratulations on a successful LOI. LRO has returned NASA to the moon.
The burn